Hi guys, I'm Prof Joe. This is part of my lecture on measurement technology within the chapter of digital technology, with the last part, which is about some digital amendments I can make in addition to the DA and AD converters we treated in the first two parts. Okay, what else is to say about digital values? The first thing, there are digital values out there already we can directly use. For example, switches. There are switches at many places, switches in your house where you can switch on the light and switch off the light, which gives you the digital state of the light directly. There are switches which can be triggered on a conveyor belt. There are switches within process automation which can be directly used because they are switches. Simple thing. Moreover, this concept can be expanded, for example, to distances by an encoder strips looking something like that. So there are different lines which are marked differently. So it's just trying to make it as good as possible. Okay, now that's marked, that's marked, that's marked. Now that's marked. Every second one is marked. And now having a sensor set over here and moving that strip along those sensors, we are able to encode distances given by that digital signal. So that's an encryption which gives you directly the dual number of the position on that strip, of the position of the sensors on that strip. Great thing. We get a digital number directly representing the position. That can be done for angles also for sure, and so on and so on. So another way of getting digital values directly. Corresponding to that, you can think of many other sensors which are able to give you some native digital signals. But the reason I'm talking about that is to give you the idea that a digital value not has to come out of an AD converter. A digital value already is given, for example, by switches. And that's a very, very, very common case of using digital signals, switches. Okay, next thing I want to talk about is, now let's assume we have some digital value. We have understood the AD conversion, how to work with that stuff. There are different options. There are different programs you could use, of which I want to mention two. That's LabVIEW and something like MATLAB or any other software like that. Whereas that LabVIEW software is very specifically built for dealing with measurements and measurement instruments. Meaning you're able to design on screen on your PC the design of a digital measurement instrument which indeed can be connected to the outside, to oscilloscopes and other stuff, which is all managed within LabVIEW within a graphical programming language, so you don't have to do real programming. On the other hand, there's something like MATLAB giving us the ability to do something with the data we have collected digitally, meaning some frequency analysis and some more decent stuff. But that's just a hint, because nowadays Python somehow gives you at least the same abilities of dealing with data due to the fact that machine learning has produced a whole bunch of libraries being usable within Python and dealing with data. That's great. That's the next thing I wanted to talk about. So there's a lot of software out there. There's the software, there's some more hardware. Now dealing with the hardware, what about the hardware to software connection? Yes, although for that purpose there are different standards you can use, and luckily which are usable quite easily. Talking about the things we need to know, that's the WISA standard, the SCPI standard, which all nowadays are combined in the IVI standard. The WISA standard being the part of the system which deals with the connection to the hardware, the SCPI being the part which deals with the commands supplied via that connection to the hardware. The thing you would deal with mostly is SCPI, which is a simple language which lets you set up, for example, the output voltage of a voltage source, or which lets you collect the data of an oscilloscope and so on. And an example of a command for that would be, for example, you could select channel 1 as source of the signal. You could get the data in form of ASCII values, and now finally you could require the data by the third command. Those commands are sent via WISA to the hardware, which most of the time is able to interpret those connections. The connections here can be via USB or LAN and so on, but that's the stuff we don't have to deal with because it's all done by standards, by some additional software you can install for free. That's the WISA driver you can get from National Instruments, which makes your own PC able to talk to different measurements, instruments and oscilloscopes out there, which most of the time, really most of the time, will support those standards. I would say nearly all of them supports those standards at least, but sometimes a little bit more. Okay, now how that all can be done. There's a library, for example, PyWISA. Install the NEWISA driver. Get the Python library PyWISA, and you're able to directly submit those commands to any measurement device connected to your network. If you want to know more details about that and some examples of Python code and so on, just ask the AI-Tutored down below. It can give you awesome examples, and again, it's the most easy way to program your first connection to a measurement device would be just to use the AI, because it is able to give you all the code and all the commands and all the hints where to get the drivers and so on. Okay, if you like that stuff, feel free to subscribe. That's the end of chapter Digital Technology. Next two chapters will be about sensors, whereas that digital part we talked about in just one chapter for sure is larger than the stuff I explained to you. See you next time.